This is the first lab with the themes, and here you will first realize an active bandpass filter. So it consists of a high pass and a low pass filter cascaded together. And there's a reason why it's on the second stage, because we may want to eliminate any high frequency noise. So this one is on the second stage. Now, there are two ways to make this possible. You can use two op-amp stages, so two active stages, or one stage can be a passive filter and the second stage is an active filter. You may want to use an active filter to be able to control the gain. So otherwise we won't have any gain. So that's why active filters are a lot better. And the bandstop filter has this arrangement. So you use a low pass filter and a high pass filter and then a summing amplifier. Now you need to do your own research here in this open-ended problem. We're just giving you the specifications roughly, and you will do some literature research, looking at some textbooks or web resources and come up with your own idea. The criteria I have here is for the bandpass filter, corner frequencies of 104 Hz and 14.4 kHz, and a gain of 18. So your values should be as close to these values as possible. So it should be within 5%, up to 5% different. So instead of 104 Hz, so this might be maybe 100 Hz. And similarly, the gain can be maybe 19 or 17. Now, I gave these numbers specifically, so if you're careful, you should be able to realize using the components in analog discovery without using too much resistors in series or capacitors in parallel. So you're gonna actually find out that you can easily realize these. And once you have your design, again, in your design, you should always consider the component values. So you will be designing a band reject filter having these specifications. So band reject filter rejects these frequencies in between these two ranges. So it passes all other frequencies except those in between two corner frequencies. So you need to draw this using some editing program and include your findings. Then you do a multi-sim simulation, and I specified the op-amps you should use in multi-sim. So based on your specifications, now you're actually examining if this is gonna really work, and multi-sim is gonna probably ease your frustration, because if it works here, most likely it's gonna work in analog discovery, and you're gonna use the ACE analysis and figure out the corner frequencies and maximum gain. Make sure to include the screen capture of schematics and waveforms with the cursor shown. And again, realize the band reject filter. And these are some suggestions. It doesn't have to be exactly the same, so you should look for something that gives you a nice plot. And then you will realize the circuit in analog discovery, both the band pass and the band reject or band stop filter. On this one, you will need 3 op-amps. In your kit, you got only 2 of the OP27. So use those, and the last one, for the last one, the summing amplifier, use the OP37 op-amp. And in multi-sim 2, use that OP37 as the final stage. And again, use the network analyzer tool to get those corner frequencies, mark them before taking screenshot. Always include breadboard picture for the circuit and the schematics for the multi-sim. And then we will compare all three results, the hand calculation, simulation, and actual hardware. Now, I want you to divide this into three carefully in a fair manner. So you got 3 persons in your group. The first team member might do the Prelab 1, the calculation of the bandpass filter, and then do the analog discovery of the same part. And then second person might do the band reject calculation and do the hardware portion of the same. And then the third member can just do the multi-sim. And then now there would be something that we should do in the upcoming team labs. This person doing the multi-sim should involve in the analog discovery portion. So you should rotate these roles. So I'm just giving you some guide on how you can divide, and you need to provide me your proposal, how you want to divide. Just providing this suggestion. Now make sure that you have each member's contribution in the lab report, and you will also do a presentation, schedule a presentation with me, and then do a presentation. So we will arrange that and make sure you understand all the requirements, and always get in touch with me. So we're gonna arrange a virtual room for your questions and just see how you're doing, and let me know if there are any questions.